In our video lecture session, we will be discussing about the problem solutions technique in ANSYS, post-processing principle and how to get the results and how to validate those results and how to view different results, maybe how to inquire result, how to plot result and how to list the result. These are our learning objectives, and at the end we will be applying this principle over the projects to better understand this principle. If you see the solution, before going to solution, you can see the pre-processing is ready. Once you do the pre-processing, that means you understood the problem, your primary objective also in your aerial view of mind. You have assigned the boundary conditions, load conditions and type of solutions. Material properties also you have assigned. So, when you go for the solution, you need to understand the type of analysis which you are going to execute. This is the reason why the FEA based software are playing very important role in designing process. And this result which you are expecting from the FEA software are in future directly linked with your manufacturing data, and in case of redesign you get the primary decision out of the results whichever you are plotting. So when you do a new analysis type, you need to understand that how you set the type of analysis based on your condition, the new analysis type. So typically if you see, the analysis types are broadly classified into 7 categories. The static analysis, which is for the structural static case. Modal is basically for the frequency response or natural frequency or mode shape. Harmonic is the forced vibration condition and the harmonic is linked with the modal. And transient is nothing but the dynamic analysis where you have time constraint and you develop this. And spectrum is basically the spectrum wave or the earthquake which you are talking about, and you are going to validate this type of conditions. And the AGN buckling is the typical buckling load which you apply, and finally the higher order dynamic condition substructuring. And before going to this setting solution control, I will show you that how you can set your analysis type. Once you go to the solution analysis type, here you can see new analysis. Here you have all those type of analysis whichever is shown. And then you go to the solution control. Inside the solution control, you typically understand the basic transient solution options, nonlinear and advanced. For different type of analysis you have configuration. But when you do the structural analysis, that is static, the analysis option you have to configure small displacement static, because your response is within pure elastic limit. If you go for the large displacement, that is in the nonlinear case. And time stepping is whatever the problem you solve, you allow the iteration for certain time, that you can select program chosen. And if you want to divide this into some sub steps, the maximum or minimum number you can also assign here, this particular solutions. The control areas and items, these are the options which you can directly set. And next is the steady state analysis dialog box, which you can see here. So this directly you can get here the solutions analysis type analysis option. Analysis type, you can see the solution control, and you can have load step option. You can see the output controls and various controls you can have here directly. You can see the solution control, solution options. For nonlinear case, for advanced case, you have the typical controls. And if you see the load step option, here also you can see the output controls and solution printouts and so on. So all these options will be configuring during our corresponding projects to better understand the application criteria. this already I have shown the nonlinear analysis tab, and this particular options will be using during the project applications, and we will understand each parameters why we are applying this. If you see the equation solver, the frontal solver, sparse solver, Jacobi solver, preconditioning, INC Chokleski, and inter-auto, these are different various methods which you use during solutions. Here you have typical conditions, program chosen, sparse, preconditioning CG, and iterative, the equation solver. And frequency based analysis, when you do, you use this frequency tab also, and for nonlinear you have the creep conditions also, you can see here. And for advanced nonlinear you have the transient scenario where you have time based constant, and you can apply this. And in case of basic, you have the basic solutions which is shown in our slide. So if go for frontal solver, the default for linear analysis and default for nonlinear analysis is the sparse solver, and the memory required is very important. This very low memory is required, and size of the model up to 50,000 to 5 lakh. So 50,000 to 5 lakh, if you have the degree of freedom, you can directly take this type of solving conditions where you require maximum 4 GB of RAM, and you can solve this type of criteria. And when you go for nonlinear default problem, medium category problem, you can go for sparse solver, and here also you can go 50 to 5 lakh degree of freedom, and memory required is medium. You can have this also till 4 to 6 GB. And for thermal, magnetic, and advanced acoustic and multiphysics analysis, you go for Jacobi, because here you can find this type of solver, because this type of analysis we are not discussing in our video lecture. A preconditioning CG, you can see this is also linear analysis for very large. So you can see here 10 lakh plus degree of freedom it can solve. Here you need 60 GB to 64 GB as the criteria, and so on. And when you solve the problem, you need to ensure about your precision. This option is used for the preconditioning, the equation solver, for the precisional control, that you have to set inside the options for getting the required precision. And memory options also, you need to control the memory, whether you have sufficient memory as that of your RAM and your graphics support, that you have to understand here. And when you solve the analysis problem, you can directly get the dimensionality of the problem, degree of freedom of the problem, and the analysis type which you are doing. So before solving, you need to ensure that this type of solving prompt option you are getting at the end. Just like that, if you see a solving a problem, I will go to solve current load step, and this type of options you are getting, the status command, the problem dimensionality, the degree of freedom, analysis type, and the matrix which you have formed f equal to kx, that is symmetric, is shown or not. When you go for OK, you can see the solution is done. So if you encounter any problem, you will never get this message. So you have to care that you are getting this particular message. When you do the post processing, you have two type of post processing. One is general post processing, one is time history post processing. General post processing you do for ordinary problem like structural analysis, modal analysis, and buckling analysis. When you do the time history based analysis, that is a transient phenomena or higher order dynamics analysis or nonlinear analysis, you need to use the post processing through time history post processor, which you can see directly here. You have two different options, general post processing unit and you have time history post processing unit. When you do the time processing, it is integrated with a graph and filtering options. So these two different options are used for different types of analysis criteria. So this you have to ensure very clearly before proceeding for your problem. is very important to get the deform and undeformed shape of your model. You have the deformed shape and deformed plus undeformed shape. So how it is, that I will show you. If you solve a problem, you go to plot control, animate, deform shape. So before that I can plot the result, general post processing, read the result. Just you read the result, then you go to plot control, animate, deform results. I am seeing the deflection along Y. This is the deflections you are getting after solving the problem. But I need to see my original shape as well as my deformed shape. So what you can do is, you can go to the plot results, deform shape. Here you can see deform plus undeform. Both you can see. This is the original shape and this is the deformed shape. And when you go to plot control, animate, deform shape, here you can see deform plus undeform. And in this way you can directly see the variations also from your original shape. So original point will be there for your reference, and you can directly do the deform plus undeform. So this is deform shape only and deform plus undeform shape. These all these options which I have shown. Deform plus undeform you can apply for any problem to understand the magnitude of deflection or the strain energy which is being expressed through the node and element for your visualization sake. Here also you can set some frame numbers to better present your deformation. For example, you have certain frame rate. When you watch movies, it is also with certain frame per second. So when you go to deform shape, here this directly you can plot the deform shape. But when you go to animate and go to deform shape, here you have a parameter known as number of frames. If you increase the number of frame, the quality of presentation will be higher grade smooth, and you can directly see the smoothing factor. You can see how smooth it is during the presentation. So these are various ways which you can use. You can delay this also, you can stop it also, you can go to the next. These are some controls. And when you see the contour plot, the various parameters like principal stress, component stress, how to get, that I will show. Go to your solution, solve this problem. Go to plot control, animate, deform results, and before that you can directly go to the general post processing, read result, first set, and directly you can go to plot control, animate, and deform results. I am going for stress. Here various stress factors are there. You can see out of that von Mises stress we used to plot in the first primary criteria. Once you go to right click refresh, you can see the plot here with the red and blue plot and in between some color gradients, and here you can see the SMX, that is the maximum plot. If you want to visualize and locate each data independently, you can go to the read results, first set, then you go to the plot results, nodal solution. Based on node you can see the result, or based on element you can see the result. Out of this, the node result is more accurate because element solution is the average result of all the elements and all the nodes. So go to the node and you can see the stress, all this component in x direction stress, y, z, and shear stress and principal stress and von Mises stress you have. Von Mises stress is the most destructive stress among all the principal shear and bending stress. This you can see. There is the plot of the von Mises. And also you can see the deflection along the particular direction, y direction deflection I would like to see. So this is the deflection along y direction, and this you can directly see in your component with different color node. And of course at the end the amount will be with the higher grade. So it is red allotted because this is fixed. So in this way you can directly control the different plot conditions through your contour plot nodal or elemental solution conditions. Like this you can plot directly. You can animate as shown before the various stress, strain and energy criteria. You can list the reaction force also. So how to do this? If you want to list the reaction force at this end, you directly go to the list result. You can see here the reaction solution as one option. In y direction reaction solution I need to list. So this you can see directly 100. Whatever the load you have applied in the opposite direction, you will get the reaction also. If you have various boundary conditions, you will get various reaction forces in multi-magnitude direction as well, which we will see in our corresponding projects. This is what the reaction force you are getting. You can list the result at each node as well. That means you would like to see the results at each node, how the response is all about. So what you can do is, here you have multiple nodes. You go to plot nodes. You can see the nodes here, all the nodes. At the various nodes you would like to see your result, list result. Here you can see nodal solution, DOF, Y component, what is happening over various nodes. You can see over all the node. If you have 1000 nodes, you have 1000 results. You have 10 nodes, you have 10 results for each point, how is varying and how the deflection is happening, that you can directly list from the nodal solution for all the nodes. In this way you directly control the different plotting conditions and you see the nodal result as well. And you can do the query also. If you want to have the result directly on screen, you can do the query scenario as well. Just like list result, you have the query results here, and go to element solution and you can find the elemental result. And if you want over the screen, you can have the y direction, or for the stress you can see also. For deflection, let us see in the y direction how much deflection I need to do. Just to read the results and go to the query results, subgrid solution, and you can directly find out here y, z, rotation, etc. So for showing this, I will take one problem so that you can easily understand this scenario. Maybe some other problem we'll look into to better visualize how the results can be visualized. There is the problem, let us say. I'll solve the problem. I'll check with the different properties, like element is selected, real constant is done, that is the thickness, material properties defined or not, that you have to ensure. Material property is also done. Whatever the boundary conditions, that you have to see whether this disk outer periphery is fixed or not. To clarify this, go to plot control, go to symbols, and you can see all applied boundary condition. This is also applied. So everything is done, so I can directly solve this problem. Now you go to the general post processor, read the result. The file is not saved, I think. Just you restart the problem if you encounter any type of problems, and directly you can execute the solution. Let us say you will be going for this and go to solution. So let us start defining a model so that easily you can understand this scenario. So I am going for solid 45. I am going for the modeling, create, volume, cylinder, solid cylinder. Let us say radius is 50 and depth is 10. I will go for the material, (200 e power 6) and 0.3, let us say, for steel is the Poisson ratio. Next, I will go for the mesh tool. The volume is there, tetrahedral free. I will go for mesh, apply it. The mesh is done. Next, I will fix the outer boundaries. I will go for loads, apply structural displacement on areas. So, these areas and below areas I am fixing. I will apply pressure over this top surface, and you apply, let us say, 10 unit. And now I can solve the problem and I will get the query result. Solution is done. This message is very, very important. Solution is done. If it is not coming, some technical problems could be there. So, go to the general post processor, query result, subgrid solution, DOF, Y. When you pick it, you can see here the value is coming, and you can generate the node also. If you want to go to subgrid Y direction at this point, how much it is, go to the generate and it will be plotted. So, you can query directly on screen. Just like that, you can query the stress as well. In the Y direction stress, how much, you can query it, and it is plotted here that this is this much. Go for OK. The SY, stress Y, will be plotted. Just like that, UY or UX will be the deflection criteria. So, in this way, you can directly plot and do the query results, query picking. It is very, very fundamental principle of doing a query like this, which I have shown. Directly you can see this. You can go for generate 3D annotation, which I discussed like this. And this particular slide will discuss here about the node picked for defining your query result. So, you can see the continuous path also for defining the queries. So, you can directly pick the curve, and over the curve whatever the nodes are attached, that you can do the analysis. And you can plot different graph based on your data, whichever is required for showing, maybe the variation of deflection along the length, or maybe the variation of the temperature along the length. This you can do. This I will be showing in corresponding project in brief. And this is the color plot, which you can see with a lower node, the blue with the red maximum. You can directly see and understand the stress contours, and here you can list and see the result as well. You can see the result viewer, where you can directly attach to your problem, whichever I have shown. This particular option you can see in the time history post processor. And it is very important to understand about PGR file. Whenever you solve a problem, there will be a PGR file which keeps or which tracks the graphic information which you are storing during the analysis problem. And when you want to display this, and once you close the problem and once you open it, this only is possible because the PGR data is stored, and that you can retrieve and you can see this. And in our coming lecture video session, we will be discussing whatever we learn for doing the analysis will apply over the projects.